When we want to solve a system that's not quite as straightforward as the previous examples, we need to follow a really specific method to solve a system with three variables. The first step is we're going to use a pair of equations and eliminate one variable using the elimination method. And then after that, we're going to use a different pair of equations, but we're going to eliminate the same variable. Let's do that much so far in the example 2. So I'm going to number my equations 1, 2, and 3 for reference. And that helps me keep organized. And then I'm going to work with a different pair of equations in each step. So if I look at equations 1 and 2, it's very easy to eliminate the y variable. So I'm just going to take equations 1 and 2, and I'm going to eliminate y by adding the 2 together. There's nothing we need to do to the equations in order to make that happen. Just add them together. And when we add, we get 4x, the y variables go away, plus 4 times z is equal to 20. Next, I'm going to pick a different pair. So since we used 1 and 2, we can either use 2 and 3 or 1 and 3. But I want to make the y variable go away again. So I'm going to use equation numbers 2 and 3. And in order to make the y disappear here, we're going to have to multiply equation 2 times 2. So if we take all the terms in equation 2 and multiply by 2, 2x plus 2y plus 12z is equal to 16. And then I'll bring down equation 3, 2x minus 2y minus z is equal to 11. Now we're going to add the two equations together, and we get 4x, y's go away, plus 11 times z is equal to 27. I'm going to number our new equations. Since we numbered the equations so far 1, 2, and 3, we can call the newly formed ones 4 and 5, just for reference again. And looking at that pair of equations, what you'll notice is that we now have a system of equations, 4 and 5, that have only two variables in them, x and z. So I'm going to take equation number 4 and 5 and combine them together. So we're going to come back together from our two previous steps, and I'm going to take equation number 4 and multiply it by -1. So -1 times equation number 4 gives us -4x minus 4z is equal to -20. And then I'm just going to bring down equation 5, 4x plus 11 times z is equal to 27. When we add those two equations together, the x's go away, and -4z plus 11z is 7 times z, and -20 plus 27 is 7. So 7 times z is 7. That gives us a z value of 1. And from this point, what we can do is now work our way back upward. So you'll notice that the previous two equations, 4 and 5, have only two variables in them. So we can choose one of them. I'll just choose equation number 4 here, and I'm going to replace the z value with 1. So 4x plus 4 times 1 is equal to 20, and that gives us 4x plus 4 is equal to 20. Subtracting 4, 4x is equal to 16, and dividing by 4x is 4. Now we have two of the variables, and we just need the value of y. The only equations that have y in them are the ones that we started with. So I'm going to use equation number 2 to substitute into, and we already have the x value. The x value is 4. We're looking for the y value, and we have a z value of 1. So plus 6 times 1 is equal to 8. So that's going to give us y plus 10 is equal to 8. And subtracting 10, y is negative 2. And that gives us an ordered triple solution. We need to remember to put them in alpha order. So our x value is 4, y value is negative 2, and z value is 1. 4, comma, negative 2, comma, 1. Remember to put parentheses around your ordered pair solutions. We'll do one more example of a system of 3 variables with 3 equations with 3 unknowns. And so in this one, let's choose to eliminate a different variable. It doesn't really matter which one you choose, it's just whichever one seems easiest to you. So I want to illustrate that. I'm going to number my equations 1, 2, and 3. And let's eliminate the variable x. And if we eliminate the variable x, I can use equations number 1 and 2 and multiply equation number 2 times negative 2. So I'm just going to bring down equation number 1, 2x plus y plus 3 times z is equal to 9. And negative 2 times equation 2 gives us negative 2x plus 4y minus 2z is equal to negative 16. Now let's add those two equations together. The x's go away, and we're left with 5y plus z is equal to negative 7. Now let's pick a different pair of equations and eliminate the same variable. So this time, I'm going to pick equations number 1 and 3. And we need to eliminate the x variable. So equation number 1 will have to be multiplied by negative 2 in order to make that happen. So equation number 1 multiplied by negative 2 gives us negative 4x minus 2y minus 6z is equal to negative 18. And equation number 3, now that I'm looking at it, I realize equation number 3 already had a negative 4x in it, so I'm going to back up here and I'm going to multiply equation 1 by positive 2. That's going to change our signs here. And that will give us 4x plus 2y plus 6z is equal to 18. Now let's bring down equation number 3. Negative 4x plus 3y plus 2z is equal to negative 4. Adding the equations together, we get 5 times y plus 8 times z is equal to 14. Let's call those equations number 4 and 5. And we can multiply equation 4 by negative 1 and just use equation 5 as is, and the y variables will go away for us. So equation number 4 times negative 1 is negative 5y minus z is equal to positive 7. And equation 5 is 5y plus 8 times z is equal to 14. Adding those together, we get 7 times z is equal to 21. Dividing, that gives us z is equal to 3. Now let's use one of the previous equations, so I'll just use equation number 4 that has 2 variables in it only, and we're going to replace the z with 3, and when we subtract 3 from both sides, that gives us 5y is equal to negative 10. Dividing by 5, y is negative 2. Now that we have y and z, we need x. Let's go back to equation 2 and replace the y with negative 2 and the z with 3. And that will give us x plus 4 plus 3 is equal to 8, or x plus 7 is equal to 8, which gives us x equal to 1. So our ordered triple solution is 1, comma, negative 2, comma, 3. Don't forget to put parentheses around your ordered triples. All right, the next one is for you to try. Pause the video while you try this one on your own. If you just want to check your solution, the solution is the ordered triple 3, -3, 1. If you want to stay tuned, I will work this one, and I may not work it the same exact way that you did because there are a variety of approaches that we can take. So I'm going to number the equations, 1, 2, and 3. And then I notice that if I just take equations 1 and 2 and add them together, I'll get rid of the y variable. So x plus y minus c is equal to -1, and -4x minus y plus 2z is equal to -7. Adding the equations together, -3x plus z is equal to -8. Now we want to get rid of y using a different pair of equations. So I'm going to choose equations 1 and 3, and I'll multiply equation number 1 times 2. So multiplying equation 1 times 2 gives us 2x plus 2y minus 2z equals -2. And then equation 3 as is, 2x minus 2y minus 5z is equal to 7. And adding those together, 4x minus 7z is equal to 5. Okay, from here, let's renumber these equations, or number them to begin with, numbers 4 and 5. And let's use a combination of those to eliminate one more variable. So I'm going to use equation number 4 and multiply equation number 4 times 7 in order to eliminate the z variable. So equation number 4 times 7 gives us -21x plus 7z equals -56. And equation number 5 as is, 4x minus 7z is equal to 5. Adding the equations together, we get -17 times x is equal to -51. And then dividing by -17, we get x is equal to 3. Now I'm going to replace x in one of the two equations. And so I'll use equation 4, and that will give us -9 plus z is equal to -8. Adding 9 to both sides, z is 1. Now we just lack the variable y. So let's go back and use equation number 1. So our x variable is 3, and our z variable is 1. So 3 plus y minus 1 is equal to -1. That gives us y plus 2 is equal to -1, and subtracting 2 from both sides, y is -3. That gives us our ordered triple 3, -3, 1. That was fun. Have a great day.